Once again, we're looking at the binary resonant schematic with L1, C1 on one side, L2, C2 on the other side. These arranged as resonant to the source frequency from the endings of the circuit. Noting also that we can employ a doubling of reactive paths through the midpoint of that circuit, which is called a binary resonant tank circuit. Right now we're in the condition of the binary resonant tank circuit. We'll note that we have 11.9 volts going in, an input amperage of 0.29 amps, splitting onto the back coil, isolated from the other system, to 0.50 amps, and into the front coil to 0.75 amps. These reactive currents are adding together on the midpoint amperage path, showing 1.24 amp. Now what we're going to do, we also have in this condition a 48-to-1 step-up transformer that we're going to ballast at this amount of current. We have a current limited supply of 1.24 amps. Now all we're going to do is simply take off the short of the primary, which is connected on the secondary to a helium bulb. And once again, note the conditions of the circuit. We note now that we have an 11.5 volt input enabling 1.8 amps, splitting into 1.3 amps onto the back coil, a near amount onto the front coil, engaging 12 to 14 volts across the primary, and across the primary amperage almost 1 amp. Now what we're going to do is we're going to have Jack go over there and turn up the voltage so this discharge can stabilize. Try to get a focus on that discharge. Jack, we got 18 milliamps. Turn it up out here. That's better. Now it seems better stabilized. So now we got 15.8 amps going in, an input amperage of 1.8 amps, dividing into 1.4 and 1.5, enabling 1.31 amps through the midpoint path through the primary, enabling 27 milliamps to go through the helium bulb. In earlier experiments we would drive 60 milliamps through the bulb, but I think they're only rated for 30 milliamps, and so they get hot. We don't want to excessively drive a lot of amperage through the bulbs. Okay, now we're going to go on the input up even higher. Note on these circumstances, now our helium will be going into the higher amperage range near 60 milliamps, but the primary voltage won't drop. Go ahead and up there, tune it to 30 volts, Jack.
To 30.
Okay, now we can better see the action of the ferromagnetic transformer being placed within the confines of a tank circuit. We have an input amperage of 2 amps at 30 volts. We have it splitting into 2 amps on the back coil, 2.46 amps on the front coil, and on the midpoint path we have 2.75 amps. We have more amperage going through the transformer primary than is inputted by the wall volt supply. But however, our primary volts have still remained at 12.7 volts, and now we're displaying an amperage of 58.5 milliamps through the helium bulb. See if we can focus on the bulb, Jack, if they can see it. We can put some light down.
Yeah, I got the bulb.
Okay, then quickly we're going to try a couple other bulbs. This one appears to be the krypton.
Whoa! What was
Oh,
that?
something happened. Oh, I blew my transformer. I can't do that. I forgot. That's the end.
Oh man, I heard that thing starting to buzz.
It's overload. Put the end on.
The end?
Yep.